Hello everybody, I'm just going to talk you through chromatography of plant pigments. So after I have done this, can you please open up your past papers and you should have mark schemes and just test that you can answer all of the questions on this. So first of all, how do we get the plant pigments out? We have to take some leaves and we grind them up in a mortar and pestle with sand. The sand breaks open the cell walls and lets the pigments out, and then they dissolve in a solvent which is also in that mortar and pestle. And then we want the pigments that are dissolved in the solvent, so you take the ground up leaves and you pass through a filter, and then you collect the nice green filtrate at the bottom. So what do we do next? The first thing is you prepare your chromatogram. So you imagine that you have this piece of chromatography paper. It's not in the tank, it's just sitting on the desk and it's nice and clean. And the first thing that you have to do is you have to cut that chromatography paper to fit the tank. It should never touch the edges of the tank. And once you have done that, you draw a pencil line just 2 centimeters from the bottom, and that is called the baseline, or it's called the origin. And then you have your green filtrate from up here. You dip a micropipette into that green filtrate, and then you add it to a little dot that you have put on the origin line, and you let it dry. And then you add another little dot and you let it dry. You do that maybe 6-7 times, drying it with a hairdryer in between, so that you've a lovely concentrated spot of plant pigment sitting on that origin. Remember, the line, the origin or the baseline, is drawn in pencil because pencil does not dissolve in that solvent, and so it won't contaminate your chromatogram. So you still have the paper outside the tank. So you should have the lid on the tank and you add solvent to the tank. Remember that the solvent is going to have to be below the origin line. That's really important. You put the lid on the tank, you add in your solvent and you let it sit so that the air inside the tank becomes saturated with solvent before you actually add the chromatography paper. So then the next thing you have to do is you have to run the chromatogram. So this really refers to this picture, which is up here. You suspend the chromatogram in the solvent. The pencil line, as I've said, must be above that solvent. And it's really important, if you're running more than one pigment, that the chromatogram is not at an angle. If you have chromatography paper at an angle, some pigments get the solvent more quickly than others, and that would not be good. So you let it run. You stop it whenever the solvent is very near the top. You don't let it run over the top. And whenever you lift it out, immediately you mark that solvent front. I usually do it by nicking it with a pair of scissors. Some people use pencil, but it's important that you do that because as soon as the solvent dries out, you cannot see where the solvent front actually was. So this is what you would expect in a chromatogram. There you have the origin, and here we have 1, 2, 3, 4 different dots. Each one of these is a different plant pigment. Each of the pigments are different sizes and have different solubilities in the solvent, and some the smaller, more soluble ones will travel much further than the larger pigments. Down here we've got chlorophyll B, which would be a green pigment. Then we've got chlorophyll A. It will look green, but in closer inspection it's a little bit blue-green. Then we've got xanthophyll, which is a plant pigment. It travels a little bit further, it's yellow-brown. And then we have carotene, and it has travelled nearly to the top and it is yellow. So pigments can be identified from their colour, but what we have to do is then, for each pigment that we're trying to identify, we work out the RF value. So as you know, those RF values have to be less than 1. So if in your exam you have a value which is greater than 1, you have done that incorrectly. So to work out the RF value, it's the distance moved by the pigment, and you measure the distance from the origin line to the centre of the spot, divided by the distance moved by the solvent. So let me explain that to you with the picture. So if I was doing carotene, the first value would be the distance from the origin line to the centre of the carotene spot. So that would be on the top of the equation, and then I would divide that by the distance between the origin and the solvent front. So you would then look up tables and you would be able to identify the plant pigments that you have from those tables. So every time you do this experiment, so if you're comparing plant pigments in different leaves, you have to control variables. And here are some of the variables. The type of chromatography paper. Some chromatography paper is thicker than other chromatography paper, and so the pigments would move more slowly through it. But if you're comparing the pigments in two leaves, keep that chromatography paper the same. You need to use the same volume of solvent, the same type of solvent, the same concentration of solvent every time you do this experiment. And ideally, the mass of the leaf that you grind up in that fixed concentration and volume of solvent, that should be the same. So make sure that you keep those things the same. Unlike the experiment that you did last year, you do not need ninhydrin. We used ninhydrin to make amino acids visible, but these plant pigments are visible, so no ninhydrin is actually needed. Just a couple of other things. It's important in all chromatography that you prevent contamination. So how would you do that? You handle the chromatography paper only at the edges, and you never set that chromatography paper directly on the desk. You usually would have a large A3 page and you would set the chromatogram onto that A3 page. Now remember, look up your past paper questions and see if you can answer all of the ones that are based on chromatography of plant pigments.